Hello everyone, Mr. Minix. My name, math is my game. Here I'm joined today with my best Algebra 2 group ever, and I'm not just saying that. So today we're going to dive deeper into the world of right triangle trigonometry. Earlier I brought up a tab of Google Chrome, and there was an image of Bill Cosby there. Now, I don't know if I still have that open. Apparently I don't. But anyway, there is a reason for that. So let's go back to our trigonometry for a second. We said that the sine of theta is a ratio. We actually didn't make this super clear, but the sine of theta, let's see, saddle, we talked about saddling our horses. So what's in the numerator of this ratio? Our, O, starts with an O. Some part of a right triangle that starts with an O. Opposite, good. So the sine is the oppose, I guess that's got two P's in it. Opposite over the hypotenuse. And that's got an E in it. And if we continue this, then we would say that the cosine of theta is the adjacent. Friday the 13th is coming up. Go watch Friday the 13th. It's a good movie. Is that Jason, Friday the 13th? Okay. And then the tangent of theta was toward other adventures. So tangent is opposite over adjacent. Good. Now, some of your geometry teachers did a fantastic job of telling you the tangent and sine and cosine are all related in some special way. They gave you actually they gave you the first of several trigonometric identities. And if you take trig, you're either going to love them or hate them. If you're good at algebra and manipulating algebraic expressions, you're going to love trig identities. But let's just suppose for a minute that we took the tangent. Well, no, not that we took the tangent. That we took the sine of theta, and we divided the sine of theta by the cosine of theta, just to see what would happen. And I'm going to shrink this stuff and get it out the way, so I could do this a little bit bigger. What if we did the sine divided by the cosine? Now, making a few substitutions, and I'm going to abbreviate. The sine is opposite over hypotenuse, right? And the cosine is adjacent over hypotenuse, right? Now, a few weeks back, actually a few months back, we studied how to simplify fractions. So this is the opposite over the hypotenuse multiplied by the hypotenuse over the adjacent, and the hypotenuses cancel, and we're left with opposite over adjacent. But wait a minute. What's the opposite over adjacent? That's the tangent. That's the tangent. So what we're saying is that the tangent of theta can be found by dividing the sine of theta by the cosine of theta. I love that. That's a trigonometric identity. It's very important. It's very helpful. It makes our job so much easier when it comes to evaluating the sine and the cosine and the tangent, especially the tangent there. And it opens up two clever jokes. You got to be pretty good at algebra to get this one. So, if we took and you got to be good at what are those things called? Anyway, if we took the sine of theta and divided the sine of theta by the tangent of theta. No, not of theta. I'm sorry. If we took the sine of b and we divided it by the tangent of b, you know what that would equal? Bill Cosby. And if we took the sine of some angle, well, suppose we had a really weird angle. Suppose we had an angle called Jareen. You know where I'm going with this, right? Okay, good, good. All right. So the sine of Jareen divided by the cosine of Jareen would be a tangerine. Good. So I guess what I'm saying is, here's one final thing that we're going to have to memorize on the unit circle. One final thing that we're going to have to memorize on the unit circle, and it's the tangents, okay? It is all the tangents. So what I'd love to do with these is start with the tangents at the POLES. And before we do that, I've got one final big idea to say. And it relates to automobiles, and I hope that doesn't offend anybody. It shouldn't. Tangents 180 out, tangents 180 out are always the same. So what I mean by that is, suppose we're on the circle and you know the tangent at one particular location on the circle. Whatever the tangent is at that point on the circle, if you were to follow the diameter across to the other side, those tangents here and here would be the same. Okay, that's what I mean by that. So there's really not much more to do to get these tangents down. Tangents 180 out are going to be the same. Okay. So just to be real clear again too, we said tangent was sine over cosine. Now I hope somebody remembers in terms of x's and y's. In terms of x's and y's, what was the sine? Was it x or y? The sine was the y. So the tangent then could really be thought of as y divided by x. Good. Okay. So the tangent is really the y coordinate divided by the x coordinate. That's a big idea too. Okay. Everybody on board so far? Good. So I don't know if I could do a Queen's accent or not. We just watched that video on the hand trick with the Queen's accent. Let's go to the East Pole for a minute. What are the coordinates over there at 0 degrees or 360 degrees? What are the coordinates there? 1, 0. I'm glad we got that. 1, 0. So remember what that means is the tangent at 0 is y divided by x, or 0 divided by 1. And let's simplify that. What's 0 divided by 1 simplify to be? 0. Good. So the tangent at the East Pole is 0. Okay. Well, we get another one for free, don't we? The tangent is also going to be 0 where at? At 180. So the tangent across the way is also going to be 0. Now let's go to the North Pole for a minute, and to the South Pole for a minute. What are the coordinates way up there? 0, 1, so that's at 90 degrees. So the tangent of 90 would be 1 divided by 0. Thank you for saying undefined. I'm so glad we got that right off the bat. So up top it's und. Some people are saying, can we use a 0 with a line through it? No, don't. I don't like that 0 with the line through it because most people use it the wrong way. Okay. Und, use at least the letter U, please. For your sake, for my sake, use at least the letter U. If you don't want to write und, that's fine. What's going to happen at the South Pole? It's going to be the same. Do you see why I'm asking you to use the letter U? The tangent at the uppermost portion, if you go up, the tangent is undefined, and if you go under, the tangent's undefined too. Do you see why to use the U? Up and under, tangent is undefined. We're doing all right? Okay. All right. Well, let's go to the quarters. These are easy. Easy money. If we go right here, we've been talking about that being a tapeworm, and we talked about the coordinates there being the same, right? So if you think about that, the tangent at 45 is going to be rad 2 over 2 divided by itself. And what's anything other than 0 divided by itself? It's 1. So the tangent at 45 is going to be 1. And again, like we did before, if we go across the way, down here in the third quadrant, the tangent's also going to be 1. Now, if you know anything at all about the unit circle, you know that there's bow tie angles, and the bow tie angles are related to one another. And if you know about your SIG and S signs, you know that over here we have negative rad 2 over 2 and rad 2 over 2. So it's going to be something divided by the same thing, but a different SIGN sign. So it's going to be negative 1 there, and across the way, 180 out from that is going to be the same thing, negative 1. What do we think? Easy so far? Well, I've got a trick to memorize the other ones, and I don't want to get too algebra heavy with this, but we do need to look at rad A. Okay? Does anybody know what an inverse is, or a reciprocal? If we were to raise that to the negative first power, that would be 1 over rad A, but that's not cool, is it? So we would have to rationalize the denominator by multiplying by rad A over rad A, which would be rad A over rad A squared, which would be rad A over A, right? So what I want you to know is that rad A and rad A over A are reciprocals, We all know what reciprocals are, right? Where you take a fraction and flip the fraction over. Do you see where I'm going with this? Remember what happens at the thirds and the sixths with those coordinates. Aren't they just reciprocals of each other? So really all we need to do is dial in the thirds, and we'll have the rest of this. Because we're just going to use this reciprocal idea. So let's dial in the thirds. Lock in place. So if we look at the thirds, so right here, that's 60 degrees, 2 pi, or pi over 3. The coordinates up there are, and here's the thing. How'd you know it was a half first? I'm glad you did. Yeah, you could use the left-hand trick, or what I like to do there, you could remember that it's 1, 2, 3 down. I like to look at this blue line compared to the red line, and the blue one's smaller, right? And that's my x coordinate. So yeah, the coordinates there are a half rad 3 over 2. Okay, so when we evaluate this, the tangent at 60 degrees is y, rad 3 over 2, over x, over a half. So that's rad 3 over 2 times 2 over 1. We cross cancel, and we get rad 3. So we get rad 3 right there. Let's go 180 out. Remember your bow tie angles. 180 across from that. Let's follow the radius across down here. So down there the tangent is rad 3. Now I think we kind of noticed what was happening if we went across the way from those. What happened with those other bow tie angles then in the other quadrants? Weren't they just negatives? Okay, so it's going to be negative rad 3 and negative rad 3 there and there. Okay. Finally, for the sixths, when we get to the sixths, we're just going to use the inverses of rad 3. What's the inverse of rad 3? Rad 3 over 3. So we got rad 3 over 3. 180 out, we got rad 3 over 3. And then up here we got rad 3 over 3, but it's negative, and down here we got negative rad 3 over 3. We'll pick that up tomorrow. We'll talk more about those tomorrow. I hope it's been educational and real and fun, and I will talk about a way to memorize those a little bit better on tomorrow. So have a great day.